In this presentation, we'll be talking about the neurology of sports injuries and also the neurology to help enhance athletic performance. This is presented by Dr. Alan Rudolph. The cause of injuries essentially is the failure of our body to absorb the force that's placed upon it when we are performing movements. At all times, this force is transferring into our bodies because of gravity's influence. So as we are trying to move forward, gravity's pulling us, is always pulling down on our joints, ligaments, tendons, muscles, and we need to counteract that force. Doesn't matter what the force is, if we can't absorb it, we will be injured. In an acute state, such as sports or an auto accident, or we can also have chronic absorption of force that's missed, meaning repetitive movement types of injuries. Muscles are our body's primary force absorbers. They are the shock absorbers, like the shocks on a car. Muscles are the shocks for our body. But most importantly is the nervous system controls the muscles, and then the muscles absorb the force as the nervous system is able to prime the muscles and get them ready to absorb that force. So when force enters the body, what happens? Well, normally it's absorbed by the muscles and we continue on with what we are doing. Injuries occur when the force isn't absorbed by muscles and other tissues become the primary force absorber. The other tissues not designed to deal with that force overwhelmed, resulting in the cases of bones, we'll have fractures. With tendons, we can get tendinitis, or we can actually rupture the tendon. With the meniscus in our knee, we can have fraying or tearing. With spinal discs, we'll get bulges or herniations. Or potentially we can have other muscles that now they're asked to do work they're not designed to do, and they'll get pulled, torn, or sprained. So we need to look beyond the site of the injury to see what's causing that instability around that joint and be able to fix that, which will then help the body repair faster. Because if we don't fix what caused that improper force displacement, we're more likely to re-injure, and most likely will increase healing time. So just to review that, so if we don't look beyond the site of injury, we're going to have to increase our healing time. We're going to increase the chance of re-injury. We'll have increased pain, increased inflammation, decreased range of motion, and decreased strength. See, the body wants to heal itself, so if we can increase the stabilization around that joint by figuring out which muscles weren't doing their job and which part of the nervous system wasn't allowing the muscles to do their job, we can increase that stabilization then, which will decrease the healing time, decrease our chances of re-injury, decrease the pain, decrease the inflammation, increase our range of motion, and increase strength. Well, why wouldn't the muscle absorb the force? Well, two things are needed for the muscle to be able to do its job. First, the muscle must be able to turn on at the right time. So when your foot hits the ground, for example, and force enters the leg, the muscles must turn on at the exact moment to absorb the force. If the muscle is even 1 millisecond too late, the force will have already transferred to another area, most likely another muscle or into connective tissue such as ligaments, tendons, cartilage, things like that. Secondly, the muscle must have enough strength to absorb the amount of force that's entering it. So for example, if you fall off a roof or you're in a car accident, even if the muscle turns on in time, the amount of force is much too great for your body to absorb and ends up getting transferred elsewhere. And so that leads to the different injuries you would incur from those types of accidents. However, strength is not the key factor to injury. The main factor is the inability of the muscle to turn on at the right time. However, strength does become the key factor after the injury. Because during that injured phase of rehab, you lose strength due to atrophy because the muscle cannot fire because you're favoring it. You know, if it's a broken arm, you have it in a cast, or if it's a sprained ankle, you tend to favor that foot and work with the other foot and not put as much force into the weaker areas. Now, brain control, muscle coordination depends on input from the muscles and joints of the body. See, the brain is driven by the information it receives from the mechanoreceptors and proprioceptors, basically specialized nerve endings from the joints and muscles. The spinal column and feet contain by far the greatest amount of receptors sending information to the brain. The upper neck contains the greatest amount of these receptors in the spine. Joints with abnormal alignment and motion send signals to the brain that affect the brain, not only reducing the capacity for other brain functions, but causes an abnormal response to the muscles that control movement and coordination of the body. See, if the brain's getting the wrong signals, it doesn't quite understand where those body parts are, and so you can't respond as quickly as you'd like to. I'd like to see happen, and that's where the injuries can take place. This information is all coming from Guyton's Book of Physiology back in 1991. So this isn't brand new information. This is stuff that's been out for quite some time. So think of it like this: muscles are like light bulbs with dimmer switches, right? The brightness of the bulb is equivalent to muscle strength. Your switch is the brain. Doesn't matter how bright the bulb is. For instance, it doesn't matter how strong the muscle is. It doesn't matter if you can't make the muscle turn on. So for example, you have a running back running down the field. He makes a cut and there's no one around him, but he blows out his knee. Well, why now? Why is it, he's done that move 100 times during practice. Why is it during the game that things change? Well, you have the stress of the game, you have the adrenaline. Basically, the situation changes and the brain fails to turn the muscle on in time. That's why it's so important to train, if you're going to practice as close to how you would play at game time in order to make sure that your muscles respond in a way that's appropriate for how you're going to perform at the time of the event. So why is the muscle weak? So we're looking at this diagram of what's called the ventral horn cell, central area state, threshold. These are all terms that we talk about in neurology as to how the nerves affect muscle response and muscle firing. So in this example, you can see here the right brain is going to be sending the signal down through your spinal cord to what's called the ventral horn cell, which is the last cell that fires to the muscle. See, what ends up happening is the right part of our brain is firing the signal over, but the left side of our brain is supposed to be inhibiting what are called inhibitory neurotransmitters, inhibitory neurons that are keeping the threshold of that muscle's ability to fire further away than what we would like to see. So if 0 is where the muscle can fire, the inhibitory neuron is keeping it below 0 or further away from 0 than we should see it as far as wanting a fast reflex. Well, the left brain, what it does is it sends down an inhibitory neurotransmitter, or an inhibitory neuron I should say, to inhibit the inhibitory neuron. So basically what we're doing is we're turning off the switch that is not allowing the muscle to come to firing threshold as fast as we would like it to. And if that side of your brain, in this instance, if the left brain isn't inhibiting the inhibitory neuron, then the firing threshold of the muscle, it takes longer to fire. So there's a delay. And even if it's a split second, it's still a delay that if you're trying to play sports, split seconds are a big deal, especially if you're trying to make a fast cut on a football field or a basketball court, and the muscles don't engage as quickly as they should, and that's where we see the injuries take place. So in order to take this to the next level, we have to think of it in these terms. The muscles have to turn on at the right time, in the right order, at the right intensity, for the right duration, and also turn off antagonistic muscles. So it's a matter of, can you turn on the flexor muscles and turn off the extensor muscles? Can you bend and contract? And the speed, basically, and force comes to fruition the faster we can flip that switch, and that's all based off of neurology. Very complex. Don't worry about it. That's my job. That's what I do as a functional neurologist. I'm trained to look at these areas of the brain and the nervous system and determine where are the switches that aren't working as they should, and help us be able to stimulate those areas in ways to make the switches work faster. So going back to these injuries, once the injury occurs, we need to find the reason for it. So we do use a technique called muscle balancing to find out which muscles are working, which ones aren't, which parts of the brain aren't allowing those muscles to work, and then stimulate the brain with input from the body to change the frequency of firing to the switches, controlling the muscles and restore function to the muscles. Now we can begin rehab, because now we have the muscles balanced around that joint, and the muscles will be working as a unit, and we can get them to come back to health faster. Otherwise, it's a lot of wasted time and energy, and things take a lot longer than they need to. Because every time now you move, it's like taking 2 steps forward and 1 step back. You're going to be gaining some strength and mobility and stability, but at the same time, because you don't have the muscles balanced around those regions, you end up irritating the tissues just as much as you're trying to help them. So advantages of the muscle balancing. We're turning on the muscles will provide stability during forceful movement. So if we do, pre-event, pre-training, do our muscle balancing evaluation, find which muscles are working, which ones aren't, get them balanced out, you're going to have a more stable system on which to do your sporting event from. But this is the bigger part, is it prevents injuries from occurring. That's huge, because now we look at high school athletes. If these kids get hurt right away at the beginning of the season, basically they're pretty much out for the rest of the year, because by the time they recover, 6 to 8 weeks is about as long as some of these high school seasons for sports lasts. But we can also change performance. We can get their body to move quicker, faster, be stronger, and react in ways that make it an advantage to be able to work towards their potential. So this was a study that was done when they took 50 athletes and evaluated them for agility, balance, reaction time, kinesthetic perception, and power. The control group improved 4.5% at 6 weeks, but the adjusted group, the group that was worked on by chiropractors, improved 10.6%, or 2.4 times in the same space or same amount of time. Then they kept on going for another 6 weeks, and they saw another 6% increase in their abilities with the type of work that we were doing. So different athletes that have used the muscle balancing, Lance Armstrong, you can look up his chiropractor. His name is Jeff Spencer. He's big into muscle balancing and using lasers. And the NFL, Jerry Rice, he's actually now a spokesman for chiropractic care. He was saw a chiropractor for basically his entire career, and he contributes a lot of his stamina on it, and more likely his endurance, and able to play for many years, to the fact that he was balanced when it comes to his muscles. Same with London Fletcher, Karl Malone, John Stockton, two very long play in the NBA, and they contribute a lot of their success to having continual chiropractic care. The entire Arizona Diamondbacks team, they had a team chiropractor. Evander Holyfield has been seen multiple times by a chiropractor and I'm familiar with down in Houston. And then a decathlete, Dan O'Brien, who's also seen by a chiropractor. So just as a review, all injury is caused by an inability to absorb force properly. The nervous system controls the muscles, and the muscles absorb the force. Muscle balancing designed to get to the cause of the injury. Muscle balancing can be used to enhance athletic ability and also prevent injuries.